Hello everyone, uh, welcome to today's session. In the last video we have discussed few problems related to the Z transforms, and we have come to the conclusion of the hyperbolic functions, and we have made a note of it for Z transform of cos h n theta and sin h n theta, and we have written it down. Similarly, we have few more Z transforms, so you can make a note of these, since these kind of Z transforms can be asked for many such problems in your exams, and you can directly write the substitution for these Z transforms. So some of the Z transforms are for Z transform of cos n theta. Nothing much to replace. In place of Z transform of, we have discussed Z transform of cos h n theta, right? In that we had one term z square minus z cos h theta, right? So here that h term is there, right? That hyperbolic term, that's not there. Rest all the things remains the same. That is z square minus z cos theta divided by z square minus 2z cos theta plus 1. There was an h right here. That h is not there. That's it. This is only for cos n theta, not an hyperbolic function. Same goes with sin n theta. What was the z transform of sin h n theta? The same thing. We should not write h. That's it. This is for cos and sin n theta. Similarly, we have z transform of a power n cos n theta. Here we need, in place of there is no h right here. So in place of z, right, we need to add a into z. That's it. Okay, because we have a damping rule says that a power n into anything, and we need to replace the value of z by a into z, right? We had one damping rule. Same thing we are going to apply it here. In place of z, right, we need to substitute replace it by az. Okay, same goes for z power a n sin n theta. In place of z, we need to write it as az, and in place of 1, we need to replace it by a square. Okay, so these are some of the standard Z transforms, so you can make a note of these. And now we are going to continue with some more problems in this session. That is, the first problem is Z transform of n plus 1 whole square. So this is a simple problem. So here use the identity a plus b the whole square. So what is a plus b whole square? That is a square plus 2ab plus b square. So now we are going to apply that a square, so n square plus 2 into n into 1, so 2n plus b square 1. So now we are going to use the linear property, and we are going to split the Z transform. That is Z transform of n square plus Z transform of 2n plus Z transform of 1. So now Z transform of n square plus this 2 is constant, right? So the constant term we can take it outside, and we can write it as 2 into Z transform of n plus Z transform of 1. We can take this outside through, we know that the linear property says this. So now that that's it. Now we need to directly write the Z transform of n square, that we have discussed it. Z square plus z divided by z minus 1 whole cube plus 2 into Z transform of n is z divided by z minus 1 whole square plus Z transform of 1 is z divided by z minus 1. So that's it. So now we need to just simplify this. Take the highest degree term as the denominator, and by taking the LCM, that is z minus 1 whole cube. So this z square plus z remains as it is. It remains as it is. And now here, since there is z minus 1 whole square, we took z minus 1 whole cube outside, right? So we need to multiply one z minus 1 term along with this 2z plus z into, there is z minus 1. So in order to make this as z minus 1 whole cube, we need to multiply z minus 1 whole square. This is basically, I have just taken the LCM. You guys might be knowing this. So now just simplify this. Multiply this 2z square minus 2z plus z into what is z minus 1 whole square, that is z square minus 2z plus 1. A minus b whole square identity. Further simplifying, we get plus 2z square minus 2z z cube minus 2z square plus z divided by z minus 1 whole cube. We can cancel some terms here, that is 2z square and minus 2z square gets cancelled. So z plus z is 2z and we have here minus 2z. So we can cancel these three terms as well. So what are the terms remaining? Z square plus z cube divided by z minus 1 whole cube. So this is the required answer. So now we'll solve some more problems. So this is the next question. Z transform of 3n minus 4 sine n pi by 4 plus 5a. This 5a is completely a constant, okay, since there are no n terms or anything. So Z transform of a constant term, we can take it outside and we can write it as, here there is, we can consider as 1. So now let's apply the linearity rule for this one again, that is Z transform of 3n minus Z transform of 4 sine n pi by 4 plus Z transform of 5a. So again, now let's simplify this. We can take this 3 outside since it's a constant, Z transform of n, minus again we can take this 4 constant, sine n pi by 4 plus this 5a is a constant, right? So 5a into Z transform of 1. We can take it, since the 1 is remaining, so we can take it as 1. So now let's simplify this further. 3 into what is the Z transform of n? Z divided by Z minus 1 whole square minus 4 into, now we can see that this corresponds to sine n theta. In place of theta there is pi by 4, right? And we have already written a note of some of the Z transforms and we have written for sine n theta as well. So what does that say? Z transform of sine n theta is given by Z sine n theta divided by Z square minus 2Z cos theta plus 1. This is given. So this is not a hyperbolic function, so there is no h term, that's it. So in place of sine theta, right, we need to replace it by pi by 4, that's it. Okay. So now let's write this. So this becomes Z sine, in place of theta, pi by 4 divided by Z square minus 2Z cos pi by 4 plus 1 plus 5a Z divided by Z minus 1, the Z transform of 1. So now let's further simplify this. Whole square minus 4 into Z into what is sine pi by 4? We have a standard value for sine pi by 4, right? That is sine pi by 4 means sine 45 degree. That is equal to 1 by root 2. So you need to be knowing this. You have studied already this in the lower classes. Z square minus 2Z into what's the value of cos pi by 4? It is again 1 by root 2 plus 1 plus 5az divided by Z minus 1. Let's further simplify this. z by root 2 divided by, here the 2z by root 2, right? We can take root 2 as an LCM for the denominator and we'll write the remaining terms. That is, since there is only z square, we can write it as root 2z square minus 2z remains as it is since there is already a root 2 plus root 2 plus 5az divided by z minus 1. So now we can cancel this root 2 since both the denominators are the same. 3z divided by z minus 1 whole square, and we'll write this these two terms together plus minus 4z 4 into z divided by root 2z square minus 2z plus root 2. So we can keep this answer as it is, or we can even further simplify this by taking the LCM for these two terms. The highest degree term we can take it as LCM divided by plus 5az into z minus 1 root 2z square minus 2z plus root 2. So this is the required answer. We can simplify this by multiplying z and or we can keep it as it is. So this is the required answer. So we'll solve some more problems. So this is the next question, that is, we need to find the z transform of sine 3n plus 5. So for that we need to make a note of some of the trigonometric formulas that you have already discussed in your lower classes. So again I am just going to recall you all, that is sine of a plus b and sine of a minus b. This is the required proofs for sine of the formulas. Sine of a plus b is given as sine a cos b plus cos a sine b, and sine of a minus b is given as sine a cos b minus cos a sine b. By using these two identities we are going to solve this problem. Okay, so now let's solve this. So we need to simplify this. I have the value of a and b are 3n and 5, and I have written it. So now let's apply the linearity property again. Sin 3n cos 5 plus the transform of cos 3n sin 5. So now let's take this cos 5, right? Cos 5 and sin 5. As we know that if we substitute those values in the calculator, we'll get a constant value or a decimal value. So we don't need to again substitute the value of cos 5 as some value. So directly we can take that cos 5 and sin 5 as constant. So we know that we can take the constant outside and we can write z transform of sin 3n plus sin 5 z transform of cos 3n. So again this corresponds to sin n theta and cos n theta. So in place of theta there is 3. So again we need to apply those z transforms that we have already written it in our previous class. Okay, so now let's write those down. Cos 5 into z transform of sin n theta is z sin theta. In place of theta there is 3 z square minus 2z cos theta. In place of theta there is 3 again plus 1 plus sin 5 into z transform of cos n theta, that is z square minus z cos theta. In place of theta there is again 3 z square minus 2z cos 3 plus 1. So here we can see that the same denominators, the denominators are same, so we can add the numerators. So we'll multiply directly. I'm going to multiply this numerator, that is z cos 5 into sine 3 plus z square sine 5 minus z cos 3 sine 5 divided by z square minus 2z cos 3 plus. So now we need to simplify again. So here we can see that in all the terms the z is common, so we can take that z common in the denominator. So the remaining terms are cos 5 sine 3, so we'll write this first, minus cos 3 sine 5 plus z sine 5. Since there is z square, right, so one z remains as it is, divided by z square minus 2z cos 3 plus. So here we again arrive with the identity that we have made a note here, that is cos a sin b minus cos a sin b minus sin a cos b, right? So that corresponds to sine of a minus b. So now we'll directly write that sine of, what is a here? 3, right? So okay, cos a, so a is 5 minus b is 3, sine of a minus b plus z sine 5 divided by z square minus 2z cos 3 plus 1, z into 5 minus 3 is 2, so sine 2 plus z sine 5 is equal divided by z square minus 2z cos 3 plus 1. So this is your required answer by simplifying. So this corresponds to sine of a minus b. Okay, so we'll solve a few more problems. So this is the next problem. We need to find the z transform of cos of n pi by 2 plus pi by 4. Again this is of the form cos of a plus b. So again we have you know these formulas, we have discussed these in your lower classes. So the formula for cos of a plus b is given as cos a cos b plus sin a sin b. Okay, so now by using this formula we need to solve this problem. Yeah, so we need to solve this. This is the value of a, n pi by 2, and b is equal to pi by 4. I have substituted in the formula, that is cos a cos b minus sin a sin b. Okay, so now again we need to apply the linearity property. So we need to split the z transform. Cos n pi by 2 cos pi by 4 minus z transform of sin n pi by 2 sin pi by 4. So again the constant term here is cos pi by 4 and sin pi by 4, right? We have a fixed value for cos pi by 4, that is we have written in one problem 1 by root 2. So we'll take that 1 by root 2 outside and we'll write the z transform of cos n pi by 2. Again here the value of sin n pi by 4 is 1 by root 2 sin n pi by 2. So this is again of the form cos n theta and sin n theta. Okay, so now we'll we'll write that directly. So the z transform of cos n theta is z square minus z cos theta, in place of theta that is pi by 2, z square minus 2z cos theta pi by 2 plus 1 minus 1 by 2 into sin n theta, that is z sin theta z square minus 2z cos theta, theta is equal to pi by 2 plus, in place of theta there is pi by 2, right, n theta, so in place of theta there is pi by 2, that only I have written it. Okay, now let's further solve this. Z square minus z into cos pi by 2. What is the value of cos pi by 2? Cos 90 degree, right? Cos 90 degree is 0, right? Z square minus 2z cos pi by 2 is again 0, minus 1 by 2 z sin pi by 2 means sin 90 degree. The value of sin 90 is 1. Z square minus 2z again cos pi by 2 is 0 plus 1 by root 2 into, this becomes 0, right? So I will not write it. So this also becomes 0. So z square plus 1 minus 1 by root 2 z divided by z square plus 1. So now let's further simplify this. We'll multiply z square divided by root 2 z square plus root 2. I multiplied this minus z divided by root 2 z square plus root 2. So now there are common denominators. We can write it together. Z square minus z divided by root 2 z square plus root 2. So this is your required answer. Okay, so now we'll solve one more problem. So this is our next question. We need to find the z transform of 1 by 2 power n plus 1 by 4 power n. So this corresponds to if we consider this 1 by 2 and 1 by 4 as a, so we can write we know the z transform of a power n. Z transform of a power n is equal to z by z minus a, where a is 1 by 2 and 1 by 4. Okay, so now we need to just replace the value of a by 1 by 2 and 1 by 4, and we need to split the z transform by using the linear property. Okay, so now we will solve this. I've used the linear property and I've splitted and written it. Okay, so now we know the z transform of a power n, that is z divided by z minus a. So in place of a there is 1 by 2, so z divided by z minus 1 by 2 plus z divided by z minus 1 by 4. Okay, so now let's do some simplification in the denominator side. Take the LCM, 2z minus 1 by 2 plus z divided by 4z minus 1 by 4. Okay, take this 2 to the other side, so we need to take the reciprocal, z into 2 divided by 2z minus 1 plus z into 4 divided by 4z minus 1. 2z, I multiplied it, 2z minus 1 plus 4z divided by 4z minus 1. Again we need to cross multiply this and take this common LCM. 2z into 4z minus 1 plus 4z into 2z minus 1. I have just cross multiplied. 2z minus 1 into 4z minus 1. This is minus. So now let's multiply. 2z into 4z is 8z square minus 2z plus 8z square minus 4z divided by 2z into 4z again 8z square minus 2z minus 4z plus 1. So 8 plus 8 is 16, so 16z square minus 2z minus 4z is 6z divided by 8z square. 2 minus 4 is minus 6z plus 1. This is your required z transform of your question. Okay, so now we have two more problems. Let's solve it.